Okay, so these are the references. You can read it from any one of these. These are the topics. We will go through network layer concepts. You would have studied already this networking class, so I will not go into details, and we'll look at two types of very simple attacks and close that lecture. Okay, all right. So link layer, by now you understand. We studied in last class. So there, there are two ways of securing LAN. One is just don't secure. If LAN is being used inside home or some very kind of place where there is no chance of having attacks, then just don't do it. And that's what many people do. And low-end LANs that you have, low-end LAN switches for homes, there's nothing. And the other way is that buy very smart switches, right? A lot of intelligence, and then it will not allow layer 2 attacks. And most of the switches that you find in the market that are used in corporates and ISPs and so on and so forth have all this intelligence built in. That does it by active monitoring. Okay, a lot of things can happen, right? I mean, even now AI being applied in the switches, and a lot of learning keeps happening. They keep observing what's happening in the outside world, and then whenever there is a suspicious activity, they find it out, right? Okay. And one basic idea is, of course, to constrain the broadcast domain, that we have seen it earlier also, right? I mean, purpose of VLAN is essentially to reduce unnecessary broadcast. All right. And there may be many other methods to reduce all kind of broadcast, because switch may itself cache certain information which and node may require. Okay. And then, of course, very important activity is defense in depth, wherein we try to limit the scope of LAN, right? Okay, so basically it's nothing but locking down the LAN. Okay, I mean, you can think of locking down in many ways, right? VLAN is one way of reducing the scope. I mean, you may require, multiple level of authentication and so on and so forth. Don't let Ethernet ports exposed to outside world. You can increase the security in, Wi-Fi, not allowing WPA, for example, or some protocols. So, there can be many handshakes and so on. Okay. So that's the reason that you can see huge difference in cost between the very cheap routers and very expensive routers, 10 times or sometimes 100 times more. Okay, all right. And then ultimately, I mean, we can separate out domains for various activities. For example, even in home routers, we have guest wireless, guest login ID, and so on. What does it? So the question is that when you have guest login ID and somebody comes to your home, and you may not want to share the your Wi-Fi user ID and password, you may just give user ID, you can guess user ID and password and change it frequently, right? But what kind of features are allowed here? What is allowed? What all he or she can do? That is to be seen, right? Okay. Okay, all right. Then simply, employee, what all is allowed for employees and so on, right? So now the access rights that you have when using Wi-Fi router at home should not be same as that for a guest. Okay, guest should not be allowed to change the password and so on. So all these things are taken care of. All right. Now let's move to network layer, and you have done IP layer in detail, so we'll not go. We will go very fast and then come to the attacks. So network layer sits here above link layer. Okay, and role of network layer is to connect different islands. These are the islands of LAN. And then if there is a node here, A wants to communicate with node here or laptop here or say B, and A knows B's address, then there should be something that should route the message through multiple hops. Basically, it takes care of multiple hops. Okay. So your message, if A knows that address of B, and note that for communication, addresses are unique. Okay, whatever technology you use, addresses have to be unique for message to reach to other end. Even the real life, your and my identity is unique. Okay, and then message will go here, it will come to router, and this router will decide where to send. It may have multiple paths, right? So it will decide to send. For example, a message comes here and then it travels through this net and then comes out. And because every network has at least one router that connects to outside world. Okay, we often call it gateway router. Okay, and this way the message reaches end. So the route algorithm that works here, that looks at the message M and decides where to send, is inter-network protocol or routing protocol. Okay, so now multiple things are required. The address have to be unique, and we call it IP address. Right? Okay. Similarly, in Ethernet, address has to be unique, which we'll call Ethernet or MAC address, right? But when this was designed initially with IP version 4, the address size was limited, and IPv6 is now 128 bits. Okay, so this is limited in size, 32 bits. Okay, all right, but it is unique and it has location information embedded, right? So IP address in India would be different from IP address in US, will be different from Germany and so on. So packet can be sent to appropriate link through the distributed algorithm. Routing algorithms are distributed algorithm in traditional networks, right? We are not talking about SDN and so on, right? All right, so this is how it is. Okay, so it basically it sends message from one end to another end. Okay. Now the question that can we have analogy? Simple analogy is that suppose you have to go from IIT Goa to, you have to send a letter from IIT Goa to so some beach, say let's assume some North Goa beach. Okay, and then you just write down the address on the letter, address of the recipient and your address, and have in the letter there are contents. Okay, now you put this in. First is that it will go up to IIT gate. Okay, now so what you do is that you put this letter which has source and destination address inside another envelope. Okay, and write down the address of gate. Policeman. So policeman at the gate will receive it, remove the outer packet, which is a MAC layer packet, see IP packet, then see it will find out that it has to go to say some beach, North Goa beach. Okay, so let's call it beach X. Okay, and then it will decide, it has multiple routes, it will decide it will go to some some junction, Ponda junction, and then will put this letter in another envelope and write down on that address of Ponda junction. Okay, and then this letter will go on maybe a car. Okay, and Ponda junction, the policeman will remove the outer envelope and see it's for beach X, and will send it to another hop. From there it might travel over, say for example, truck. Okay, and so on and so forth, right? So while we can see that each hop the letter is passing through by putting another envelope on that with local address, ultimately your letter will reach to the destination. Okay, that's how. Who decides where to send? At each junction, there is some algorithm. These policemen are intelligent policemen, and they are told how to take a decision. They also have local information about traffic and so on and so forth, right? And this is how distributed routing algorithms work, that all nodes take decision, routing decision based on information that's available to them. Okay. So that's a role of policeman here, to tell where to send. If there are multiple roads, then where to send is exactly is the role of network layer. Any question? All right. So this is the router. Okay, and we have discussed in the past that why we need layer 3, because Ethernet addresses are not, they don't have location information built in, they are unique. So you cannot connect all machines in the world to layer 2. Okay, but same is not true if the, in data centers. If you happen to read data center design, most of the communication happen over layer 2, because there layer 2 you can create hierarchy, you can sequence them, you can design the network in such a way that over layer 2 most of things can happen, right? Because most of the communication happens in data center, which is within the data center. All right, all right, all right. So this is the way it is. This is the network, and there can be local area networks here and so on. Okay, but its messages pass through router, and router takes out the data link, the outer envelope, which is the data, removes a data link frame, a header, etc. Takes out the IP packet, look at the destination, and takes a decision where to send. And suppose this link is Wi-Fi, then MAC layer is corresponding to Wi-Fi. Then this router will take the IP packet out and then put it into envelope which is suited for this route. For example, is Ethernet, and put in the frame of Ethernet and send it, right? So the packet goes hop by hop. All right. This is a concept. There's a difference between layer 2 and layer 3. So the links could be of different type, but IP packet will remain the same. Outer packet, the frame may change, and frame responsibility is only for the hop, like this hop and this hop and this hop and the hop here, right? So this layer 2 protocol works only for a link, while IP protocol works end to end. All right. So this is the concept. So as you would have seen that packets, any packet that you're sending, even in real life, you are sending parcel, you need three things, right? Source address, which has to be unique, destination address, which has to be unique, and something that will go inside the packet, right? Data. Otherwise, why you're sending it? Okay. Now, unlike real world, okay, where packets are not broken into smaller packets. Okay, in internet world, the packets can be, if the packet size is very big, and the node in between, or the link in between cannot carry this large size packet. There can be technology here which cannot handle very large size packets, right? Okay, then it can be fragmented. Okay, so basically one big packet can split into multiple packets, and these packets can follow different routes. Okay, and ultimately a destination they get, again can be combined. Okay, all right. This is called fragmentation. Okay, all right. So, and when in the network here, for example, packets are being sent. This guy is sending multiple packets to destination here. They may take a different route. First packet may take this route, second packet may take another route, third packet may take this route, and so on, depending on the routing algorithm. Or routing algorithm can change also. There may be sudden congestion, for example, in this node, The second packet may be traversed to something else, right? Some other route. All right. Okay. So this IP packet you would have seen several times. Okay, and the fields are as follows. IP version number with IPv4, IPv6, the length of total length of the datagram, type of service, like whether it's a diffserv, ECN, etc. ECN stands for explicit congestion notification. Time to live, because a packet cannot remain in network forever. So otherwise some packets that don't reach destination will remain in the network forever, right? And the the network congestion can happen, right? Okay. And then IP layer, in IP packet, so this is a header, right? It's a kind of overhead, right? Inside that is useful thing, so but IP packet can contain just data or data. Of course, we are going to use some protocol on top like UDP or TCP. Then these packets will come inside, right? But looking at the header, you should know what is contained inside. Okay, so this is upper layer here. These bits will tell what is inside. Only then you can interpret it, right? Okay, so when this upper layer thing will tell inside this TCP, UDP or some other protocol. Then of course we have a checksum. Okay, checksum is a minimal checksum we use here. We don't use hash kind of functionality, right? Cryptographic hashes we don't use. And then we have 32-bit source IP address, 32-bit destination IP address. Of course, we are talking about IPv4 here. All right. Okay, and there are 20 bytes of overhead for TCP, 20 bytes for IP. So total of 40 bytes of overheads if you are using TCP over IP. And of course, application layer will also have its own overheads. Okay, there is very little that we do to provide the reliability. And there's no cryptographic MAC, message authentication code or hashes we use, right? So IP delivery is extremely unreliable and best effort delivery. And this is designed in this way, right? That there, if required, endpoints can do retransmission, but any node in between can drop the packet if there is a congestion. Okay, so packet can be dropped, packets can be corrupted, packets can be delivered out of sequence. Okay, second packet from a source can reach earlier than first packet and so on. So now it's a responsibility only of the end node to do the corrections. All right. So we can see that internet is designed in academia. Okay, it was experimental, but it flew off, right? All other technologies around that, like ATM, asynchronous transfer mode, frame relay, all this came with a lot of fanfare, served the purpose for a very short time and died. Now the beauty of internet is that it is very simple, very flexible, with minimum functionalities in that, right? It simply creates a pipe, end-to-end pipe. Whatever you put at the end, it comes out. Now it does not say that this has to be voice or data or text or movie or something else. Okay, what it says is that there is a sequence of bits. Whatever you put the sequence of bits here will come out here. Now it is left to you at the end to give syntax and semantics to this. Okay, this is in contrast to all the other technologies that you would have seen, like PSTN. PSTN mandates you to put a voice at microphone. Okay, when you're dialing in something like your PSTN dabba or box, you dial in, pick up the phone, dial in, then you are supposed to speak. You can't send bits there, right? So it's designed for voice. And then you have, for example, all kinds of other networks like, for example, you have Sonnet. I'm not sure you would have studied this, right? And T1 even lines. They have designed only for data communication at certain rate. Then you have, like you have Tata Sky, right? Old one, Dabba wala. Okay, these were designed on, or your Doordarshan channels, etc. Right? I mean, so these were designed initially, of course, over air for sending TV signals, but nowadays you over cable, which could be fiber cable, you get number of channels, live channels, right? Video channels. These were designed for video communication. Okay, but internet is not designed thinking of an application. It simply says I am a pipe. At one end you put bits, other end I will supply that, and I cannot give any guarantee of that too. Many applications don't require that kind of reliability, like the voice communication we often do. There is not enough time for retransmission of packets, right? So some packets are lost. Okay, so many applications like file transfer require reliability, so there can be retransmission. So this is the beauty of internet, that it has minimum functionality. It acts simply as a pipe. Okay, of course, this is a very simplistic picture here, but pipe can be created by interconnection of nodes, right? So there can be small pipe coming here, going there, and then going somewhere else, and then small pipe. So basically, packets are routed through network, and there is no guarantee that packets will anywhere reach, right? So all these advantages are there. Now, when internet came, that link speeds were, I mean, we used to dial in. We use modem over telephone network. So 64 kbps was maximum speed one could get. Okay, and then of course came ADSL and DSL of the world. But so that time the concept is that somehow we should get bandwidth, and it should have flexibility, and if link speed is less or link is broken, packet should retransmit from somewhere and so on, right? So it was designed around everything. There's a flexibility, then rerouting, simple routing, cost effectiveness, and so on. So, but where was the security? Security was not even there, right? So the internet is designed for connectivity. It was designed for trust. Nobody thought there can be bad guys, right? Okay. And it was thought that if you need anything more than very simple things that it can provide, then let end application take care of it. Okay. So now if you need security, you can do encryption, you can do authentication, you can do, okay. So basically we have end-to-end argument. You would have studied this in networking course, right? And we have encryption and authentication often, right? So these are the two techniques we use. Okay, we'll see how when we study IPsec and other mechanism. Right? So we have the threads, of course, we know. Even today there was a huge article in Wall Street Journal. Sorry. All right. So what I was telling is that even today is a huge article on Wall Street Journal about cybersecurity threats that are happening, but by Russian cyber criminals. Okay. All right. So we can see, all kinds of threats are possible because internet is not designed for security. Your packets are passing through n number of routers, usually 4, 5, and so on, and anything can happen in between. Okay, so we can do erase dropping, spoofing, DDoS, a distributed denial of service, modify the packet. Erase dropping is nothing but passively listening. What's happening. Spoofing, we use spoofing where you change the source IP address or something like that. Okay. Modify is that you receive a packet and then modify the contents. Okay, like man in the middle attack kind, right? You can in fact can insert viruses in the packet. You can remove some packets, and you can traffic hijacking. Like, there was a famous case of traffic has been hijacked by cyber criminals in China once. Whole internet traffic passed through China because hackers manipulated BGP, and sometimes it also happened in Pakistan. Of course, Pakistan is famous for doing some of things like that. Okay. So then a large number of attacks are possible because there is no authentication happens anywhere, right? For example, you create a IP packet, and who puts IP address there? Your software does IP address, right? Your source IP address, destination IP address. Okay, so you can send packets to anybody in the world. Okay, now it's left to you. How do you want to disturb the normal order, right? I mean, you may want to, for example, hijack or deny services at a particular server. Just keep sending IP packets. Millions of packets in a second you send to that machine, and machine has to respond back. So you have denied services to others because your packets are being processed. The question is that how can you create trillions of packets in a second? Then you have other techniques to do distributed denial of service attacks, right? But you can do that. Now you can also use wrong source IP address. You can fake it. Okay, and what is the impact of that? Response will go to somebody else. Okay, all right, you can send the packet in the name of somebody else. I mean, this is normal things that happen, right? That you may send a letter to, say, a minister or politician in the name of your adversaries and write whatever you may want to write, right? So all these things are possible here, and so we can see there are IP level problems, then ICMP and routing protocol attacks. Now the problems are, as we said, that your IP packet passes through untrusted hosts. Okay, you don't know where it's passing through and what the node can do, because the whole design is based on trust. Okay, of course there are some checks and balances that nodes that are allowed to do routing comes in trusted zone, etc. But still things can happen, and things have happened, right? Second thing is public addresses are public. IP addresses are public. Should it not be public, or should it public? Like, just about 30 years back, you would have seen telephone directories. I don't know, still they are published or not. It used to be big business. Kind of yellow pages. Okay, at least my home had a directory which had at least 1,000 pages. And then initially, of course, in a small town where I was born, it was just about 100 pages. But you from that you can find out everything, right? You can know the name of the person, where the person is, address, and the phone number. What else you need? You can do any kind of attack with this, right? Okay, so this being public IP address is a problem also, right? But this is also required. Otherwise, how can you communicate? Okay, there is no mechanism to check if someone is sending packet with wrong source or destination IP addresses. The routing protocols, of course, is designed assuming that everyone is honest. So there are a lot of attacks are possible, and some of the older protocols, like you would have seen remote login, RSHs, remote host, etc. All these do authentication based on login ID. We log in with IP address. So login is based on the IP address. That's it. If a packet comes from particular IP address, say my IP address, it will be allowed. Now I can fake anybody's IP address, right? And then send, and my packets will be allowed inside. So this is the problem with this algorithm, and any recommendation you read on security, they suggest never use this remote login. These are all old protocols. Okay, and then a lot of other features that are there, which are like fragmentation can be exploited, broadcast can be exploited. Okay, so first is that IP address spoofing. It's nothing but just use fake IP address or forged IP address, source IP address, right? You send a message, keep sending messages from your source, from your machine, faking your friend's IP address. What may happen? What can happen? Tell me. What's the result of this? You send 1,000,000 packets to a server faking somebody's IP address. Yeah, I'm asking you guys.
They won't be able to know who sent it.
Yeah, I mean, the server will notice this and block your friend's IP address. It's a very simple attack, right? Okay. All right. So this is what it is, right? I mean, you this IP address of machine A is sending it to server. Okay, server IP address is correct. Source IP address you change. These are not the same. Okay. So using source IP address of this machine, so reply will go here. Now you can use it, right? If it's your, your friend's machine or some machine, then you can always read something. Okay. All right. And then source address is a non-existent IP address. Okay, so now you can, earlier one you can use as an attack also, right? Okay, you keep sending messages, okay, from your machine, faking your adversary's machine, and it will keep on getting millions of replies, and you can do it from multiple machines. So you hire bots and send it from this machine some kind of IP message, which will send a reply to this one, like echo message or some other message, right? Or ping. So you can do that. All right. Similarly, if you give non-existent IP address, the message may be lost. It may go nowhere, right? Okay. And the way to do is that packet filtering, all intelligent switches have packet filtering, will see source IP address and see that the source IP address is correct. Okay, just a minute. Okay. All right. So similar, both ways you can do it. In grace filtering, blocking of packets from outside the network. So this is the network, and it here at entry point, you see if the source address is something that is from inside, because the person may want to do some insider attack, some kind of attack. Okay, and then this will not be allowed. Similarly, packet which are going out with IP address that of outside world, not of this domain. Okay, so we can have two kinds of filtering, ingress and egress. Okay, and some kind of mechanism can be used at higher layers. So we will study that in TCP level, TCP layer, we can use sequence numbering. Then recipient can observe the sequence numbering and then do the corrections, because it's very difficult for attacker to guess the sequence number. We'll see that this attack later. Okay, then we know that ICMP layer sits above IP layer, right? It's not so although it's called layer 3 protocol, but it is which uses IP. Okay, all right. All right, and ICMP, is used for error reporting and simple queries, right? I mean, you can ping, you can do find out timestamp, and so on and so forth, right? And it goes inside IP packet. So we have IP header, and this is where ICMP message will sit. Okay, and then the important fields are type and code. Type and code, basic code put together tells you about what kind of message it is. Okay, so we'll look at examples of this. And then of course there is a checksum and so on. For then some additional information can be there, which is part of the message, because of which ICMP message is being sent. Okay, I'm sure you would have studied this in detail. Okay, and then various combinations of this type and code are 0030, like echo reply. You send an echo message and you get a reply. If it's a reply, then type field will be 0, code will be 0, and so on and so forth. Right? So I will just look at some examples here. So a host can send ICMP message, ICMP request, and router will reply with the reply corresponding to this request. Okay, all right. And various combinations are like 80 is for echo request, 00 is for echo reply, 130 is for timestamp request, 140 is for timestamp reply. If the header contains type and code field as this, but there will be some other information in the body of the message. Okay, like we say, we send here echo request, right? Like in OS you do ping. When you ping a machine, then it gets converted to echo message. Okay, and then your machine sends echo request, ICMP echo request. Host responds it with echo reply. Like you do ping, right? I mean, it's, from your terminal. Okay, all right, with giving one IP address of a machine. Okay, all right. So this is how it is. Similarly, you can make a request for timestamp, and the receiver will send it timestamp reply. You can try all this from your terminal. Okay, and then if you send IP datagram and the router is not able to process it to send it further, then it will send error message, right? So we have a set of error messages. Now these error messages come back to host, and host will come to know about network condition, etc. Say congestion, for example, in network. Okay, all right. Okay, so it reports error condition and typically send when datagram is discarded. All right, and this is the format, right? It sits inside IP packet. So this is IP packet. So this is inside is ICMP message, and you see another IP header because the body contains a part of the original message. Okay, all right. So don't worry about it. Okay, just okay. So, and these are the different codes. Like type 3 code 0 is 15 if destination is unreachable, or if 11 and 01 is time exceeded. So this range is for different kind of cases, sub cases. All right, so you can see all this, right? And something that we use very often is port is unreachable. You send a message or UDP or TCP on a particular port, and you understand the concept of ports by now, I am sure. Okay, and then port is busy. or not available, then you will get ICMP message back that a particular port is not available. All right. Like this message here, request a service at port 80, and there is no process waiting on port 80 in the server, and you'll get a response back that port is unreachable. Please read about ICMP text or these PPTs again. Now using this, what kind of attacks we can do? Okay, so a good number of attacks happen using ICMP, right? Because again, ICMP, note that ICMP messages are not authenticated. Okay, there is no MAC or hash kind of thing, right? Who is sending? Sender, right? Anybody can send. Is sender's ID is authenticated? No authentication. So you can pose as me and send. Okay, ICMP message. Okay, now this is a problem. This is a problem, right? So you can read a lot, information about it from many sources. Of course, this paper contains good amount of information. The first is that ICMP redirect attack. So you would have noticed that there is one particular ICMP message which is called which type is 0 and code is between 0 and 3. This IP and ICMP redirect, whereas it informs about alternate route for the datagram, and should result in a routing table update. Code field explains the reason for route change. Now you can create ICMP message and ask for route change. Okay, so this will disturb the normal operation of routing, right? Okay, so this is a normal router, normal packet path, and you send ICMP redirect message. So you can, you can pass it through the attacker, right? So now you have this one, it passes to attacker. So this is possible, right? Now attacker of course can do anything he or she likes. Second attack is ICMP smurf attack, where you spoof the source address. Okay, and then you can cause denial of service attack. For example, here you're the attacker. Okay, you send echo packet to you broadcast it, okay, with somebody else's address. Okay, so what are you using? Your address using sender address, source address, or sender's address of this address. Okay, this victim's IP address. Okay, and do the broadcast of echo messages. Okay, so the attacker is doing echo request message. Okay, and using source address is victim's address, this address, and it's a broadcasting. Okay, now all the machines will receive this and send the reply back to, not to attacker, but to this machine. Okay, so it's like this. So it send one packet, it goes to all machines, and then is a reply will go to this machine. Right? Okay, it's called a smurf or reflector attack. And you can do bigger damage by this technique can be used where you can use bots, for example. Okay, and bots, all bots can send echo message to to number of machines, and then they will respond back to a victim's machine. Okay, so there's a number of ways DDoS attack can happen. Distributed denial of service attacks can happen. Okay, so we'll possibly, if we get time, we'll study about the botnet. Okay, another attack is called ICMP ping of death attack. Okay, now here attacker sends a ping request that is larger than, so create a very large size ping packet. Okay, and this large size ping packet will fragment into small packets. Okay, like small packets here. Okay, the destination machine, the victim machine, will try to assemble it. Okay, and they will request packets in buffer, and the buffer will be overflow because packet size is very large, and this machine does not know that packet size. It will keep on accumulating these pieces and putting together and overflow the buffer because it may not have the logic to check all these things, right? And this is called ping of death attack, wherein you send a very large size packet, ping packet. All right. Okay, and the large number of tools are available. Please go through this list and double click on it, and you will come to know about what are these tools which you can download, or sometimes you can hire, and so on and so forth, right? Okay, all right. So what you have studied today is that IP layer is the most basic layer of internet. A good number of attacks are possible as the IP layer and also ICMP layer are not designed for security. They are designed for everything else apart from security. Commonly used attack include IP address spoofing that we have seen. In that case, attacker can spoof the address of somebody else and then cause problem. Then ICMP can use the same techniques as spoofing somebody else's more intelligently. So these following attacks are possible: ICMP redirect attack, Smurf attack, and ping of death attacks, right? And we have studied just only few. A large number of other attacks are also possible. Okay, all right, that's all. Any question? Okay, so you must do some experimentation and then try to download some tools and see what all you can do. You can do this also on Wi-Fi. You can possibly try to, most of the Wi-Fi routers that you see around you don't have, people have not set the password. Because a router, any router or Wi-Fi router, etc., is a computer basically, right? So it has to have a login ID and password. Okay, so what experimentation you can do is that whatever Wi-Fi routers are visible to you, just use user ID as a default user ID that comes right with every router, and use default password. And unfortunately what happens is that the people who come to set it up, these technicians also don't know much about it. Okay, and also most of the people around us are not so tech savvy. I'm sure in this class there are many homes wherein people have not. You are IT student, you should do that, right? And I find many IT engineers have not set their Wi-Fi routers user ID and password. And imagine what can happen. Okay, I'm asking you a question. Can you run virus detection software in router? Like you have McAfee and many others, right? Bitdefender and many others. Do these softwares available, virus detection and protection software or malware protection software, available for routers? Yes or no? Did any one of you try to set up McAfee or whatever for your router? Can it run? Is it designed for that? Yeah, tell me.
Don't know, sir. Haven't tried.
No, because you can't do it. Can't do it, right? So now imagine you have left the doors open. Okay, cyber criminals will enjoy it. Will plant a, what do you call that, a rootkit or some malware, which will look at all your packets and steal all information that's possible. Okay, for example, if you are sending your first thing it will do is user ID password of almost all accounts. It can see everything that you're doing. If it is not end-to-end encrypted, then it can see it. Okay, so so that's a big problem, right? And now there is a claim, of course this claim can also be wrong, that Google knows user ID and password of all of us, because ultimately you are using Android phone. Most of us are using Android phone, and you are inputting user ID and password in plain text. Now this claim can be wrong. I've seen a report on internet about it, but it's possible. It's of course legally not correct, but technically it's possible, right? So if a simple message from that is, plus if you're using Wi-Fi router at home, please look at it whether you have set the password or user ID and password, and for that you have one IP address, right? The router's IP address, kind of known IP address. It's not kind of IP address used for communication, but logging in. Okay, you find out how can you do, and there's a web interface, and use that IP address for web interface to log in, and then see what is whether you have set the user ID password or not. And you go to your friend's house, please do the same thing. Okay, and imagine when we as a technical people, comp science student, have no clue about it, what will happen to a common person? And that's the reason cyber criminals enjoy all this. All right, and router is a place where you send everything. All kind of data collection can happen there by cyber criminals, and they can sell this data to anybody, right? They will come to know, for example, what communications I am doing, what I am buying, okay, what kind of insurance policies I have, and so on. All right, okay, thank you, see you on Monday.